All right, moving on here in section 7.2, I want to continue and finish up these examples. We got one more to look at in applying our half-angle identities. So keep in mind our half-angle identities, which we went over earlier, we proved using actually double angle identities. Double angle identities that we referred to at the beginning of the section. Sine of 2x equal 2 sine x cosine of 2x. Again, doubling the angle value, equal cosine squared minus sine squared x, or you can rewrite in all terms of sine or cosine using Pythagorean identity. Double angle for tangent, tan of 2x, 2 tan x, divided by 1 minus tan squared x. Half angle identities, sine of x divided by 2, 1/2 of x equals plus or minus. Again, depends on where our angle measure is as far as the sine, the value of the function. And square root of 1 minus cosine x over 2. Cosine of x over 2 is plus or minus 1 plus cosine x over 2. And tangent, you divide sine and cosine, so you end up getting 1 with the square root of 1 minus cosine x, or 1 plus cosine x. And then if you rationalize the denominator, you get sine x over 1 plus cosine x. If you rationalize the numerator, you get 1 minus cosine x over sine x. So just a quick summary of those. Now looking at problem 22, I want to find the value without a calculator of the sine of 5 pi over 12. Now I don't know anything about 5 pi over 12, but I want to rewrite it using half-angle identity and see if I can introduce one of my special angles, right? Pi over 6, pi over 4, pi over 3, or a multiple of that. Different quadrant maybe. But right now, if you're talking about 5 pi over 12, 5 pi over 12 is actually a quadrant 1 angle. If you multiply that by 1/80 over pi and convert it to degrees, you're going to get 75 degrees. So this is a quad 1 angle, so keep in mind its function value will be positive. With sine, let's go ahead and first, all right, let's go ahead and create the half angle. What is it going to be? And you might not see it, but we talked about how to easily create the half angle, right? We don't multiply by 2. So let's take that and do that. So what's 2 times 5 pi over 12 divided by 2? So again, creating a half. So if I double my given angle value and divide it by 2, right, we're creating a half angle, and we're not changing it any. It's still 5 pi over 12, but now we can reduce, right? 2 divides into 2 one time, 2 divides into 12 6 times. So that factor of 2 we divided out of 2 and 12 reduces to pi over 6, right, or 5 pi over 6. So as we go down here, we got this equal to 5 pi over 6, which again is a multiple of pi over 6, which is special angle, right? It's our 30-degree measure in actually quadrant 2. So if you need to get back a unit circle, right, we should know everything as far as function values go with 5 pi over 6. So again, that's a special angle. So with that, we can find its function values. So while we have that, let's go ahead and make mention. What is the cosine of 5 pi over 6? Well, the cosine of pi over 6 square root of 2. Cosine of 5 pi over 6, since this is quad 2, is negative square root of 2. And again, if you need to, pull up a unit circle. All right, go over here to 5 pi over 6. All right here's 5 pi over 6. What's the x-coordinate? Yeah, cosine of 5 pi over 6, again, using unit circle, equals the x-coordinate. So it equals negative square root of 2. So again, we know those. We should have our special angles down by now. We work with those enough. We shouldn't have to keep referring to the unit circle. We should be able to quickly evaluate. Should know those. But let's go ahead and use the identity. So now let's apply the identity. All right, so apply our half angle identity. And let's go get our value. So again, with sine, if we need to refer back to it, what is the identity? Sine of x over 2 equal plus or minus the square root of 1 minus the cosine of x, all divided by 2. All right, so that implies, so now I'm going to go ahead and rewrite. All right, so that implies the sine of 5 pi over 12 is equal to the sine of 5 pi over 6 divided by 2. All right, so again, here's my x, so to speak, in the half angle identity. Right, there's the x part. So applying the identity, right, what do we get? So again, applying the identity, and I'll write that over here. Let's write a note from that. All right, what do we get? We get the positive square root on the negative. We know our function value is positive with quad 1 angle. So square root 1 minus the cosine of x. So x, as in this example, is 5 pi over 6, all divided by 2, which, as we simplify it down, we know that cosine of 5 pi over 6, right, we know that equals negative square root of 3 over 2. So we have 1 minus negative square root of 3 divided by 2, all divided by 2. It's equal to, of course, 1 minus makes a plus. 1 plus the square root of 3 over 2 divided by 2. All right, so now we're looking at this radicand, and I want to simplify. We don't want to leave a fraction within a fraction. So let's go ahead and clear that out. So let's go ahead and multiply by the LCD. So we can divide that out. And remember, we do have to distribute it for both. All right, so let's go ahead and do that. So we're simplifying down. We're clearing out the fractions in this root. 2 times 1 is 2. 2 times square root of 3 over 2 is square root of 3. And the denominator we multiply by the LCD, which is 2. 2 times 2 is 4. And then we can go ahead and break that up and rationalize the denominator. We know the square root of 4 is 2. So in the end, we get our function value of the square root of 2 plus square root of 3 over 2. All right. So again, I've created a half angle, and when I did that, right, I was able to introduce one of my special angles so I could easily evaluate it. Didn't need a calculator. I could check it. I could put it in my calculator and look at that as a decimal, right? And there's an irrational number. So my calculator best is going to do is give me a rounded decimal. We can make sure they match up. What you want to check it, you could. Let's move on. Next page, a little review of both double angle and half angle in these next two problems. Says given sine theta's function value is 0.3416 and theta is in quadrant 1. Find each of the following using identities. So we have a quadrant 1 angle with theta. So that means all the function values with respect to theta will be positive. Now let's go ahead and talk about number 23. So with that, we have a sine of 2 theta. Well, we know from the identity, right? Let's apply identity. What identity? The double angle identity. And keep in mind, what is the double angle identity? The sine of 2 theta equals 2 sine theta, cosine theta. So this is equal to 2 sine theta, cosine theta. Now, we're already given sine theta, right? Sine theta holds a value of 0.3416. So this is equal to 2 times 0.3416 times, now we don't know the cosine of theta. So that's what our work is. We've got to find that. So we got to find the cosine of theta. So let's go ahead and get that. Now to find the cosine of theta, there's different ways to do it. We could use a right triangle, right? We could even use an identity if you wanted to find it. So different things we could do to get cosine's value. All right, and I'm going to use, just to review, all right, let's use the Pythagorean identity. I'm going to review back to the beginning our fundamental identity. We all know that sine squared theta plus cosine squared theta equal 1. So that implies, what, 0.3416 squared plus cosine squared theta equal 1. And then we can subtract that over, right? So that implies cosine squared theta equal 1 minus 0.3416 squared. And then we take the square root, right? Take the square root, and we'll have cosine's value, which is what we're looking for. Find the cosine of theta. So in the end, we have the cosine of angle theta equal to the square root of 1 minus 0.3416 squared. All right, let's go ahead and look at that. So if you want, let's go ahead and get our calculator out. So on our calculator, as we type that in, so let's go ahead and second x squared key the square root. We got 1 minus 0.3416 squared. Enter. I got 0.9398. Well, let's round it 4 decimal places. All right, since we were given 4 decimal places with the function value of sine theta. So we've got 0.9398 for cosine of theta. All right, well now we're good to go. So now we can go right back, right? We've got our function value. We go right back to our identity. So this is equal to 2 times 0.3416 times 0.9398. And you can put that in your calculator, and if you type that in your calculator, you're going to get 0.6421 rounded 4 decimal places. 0.6421. So there's my function value. Here's the sine of 2 theta. All right, now let's look at the next one, problem 24. All right, 24, it wants us to introduce half angle identity. So let's go ahead and write that down. So we're going to need to apply half angle identity for cosine. So we just got finished with working with that. We'll write it down. What's the half angle identity? Cosine of theta over 2 equal plus or minus square root 1 plus cosine theta divided by 2. So if we're dealing with a quad 1 angle, we know everything is positive, so we're going to need a positive square root. We got 1 plus the cosine of theta divided by 2. And we found cosine theta. So cosine theta is equal to what? 0.9398. So this is 1 plus 0.9398, all divided by 2. And as we add that up, we have the square root of 1.9398. As we add 1 plus 0.9398 and divide that by 2, and let you put that in your calculator, you'll get approximately 0.9848 rounded 4 decimal places. So there's our value. There's cosine of theta divided by 2. So again, applying our identities, right? Putting that in there, we can get to our function value. All right, it sounds a little work. Now, again, I use Pythagorean identity to find the missing function value needed for both identities, which was cosine theta. But again, we could have done different approaches. We could have used a right triangle. We could use an ordered pair. It is a quad 1 angle, been easy to evaluate with different methods. Right. So let's move on. Moving on to our last set of examples in this section. Wants to simplify some expressions. So let's look at simplifying, and we're going to do that using algebra and our identities. So a good summary of what we've been talking about here in our first two sections. Now in our first problem, we've got the cosine of x raised to the fourth power, with cosine 4x, minus the sine of x raised to the fourth power, written sine 4x. Well, my first step, all right, I'll write that here on the side, maybe a different color, is to factor. So step one, we need to factor. And to do so, let's review the different squares. Hopefully you recognize that's what we're dealing with in this example, right? A squared minus b squared factors to a minus b times a plus b. So we see here in this example, and we can write it right beneath it, this is equal to cosine squared x squared minus sine squared x squared, right? Difference of squares. So there's my a and my b, so to speak. So we factor that down, so let's go ahead and factor a minus b. So cosine squared x minus sine squared x times cosine squared x plus sine squared x. All right, a minus b, and here's a plus b. And with that, we have two identities. All right, so we need to apply identities. So if you recognize, hopefully you do, right? I'm going to go ahead and write it here in a different color. What do we have here? All right, this, right, is our double angle identity. Cosine. All right, now what do we have here, of course? Pythagorean, our fundamental identity. So looking at the second one, we've got our Pythagorean identity. So they simplify nicely. So this is equal to what? Go ahead and put it back into color. This is equal to the cosine of 2x. Cosine of 2x is equal to cosine squared minus sine squared times 1. Pythagorean identity. Sine squared plus cosine squared, or cosine squared plus sine squared equal 1. So in the end, we've got the cosine of 2x. Simplified. So it's simplified nicely. Had a little factory. After we factored, two identities, double angle and the Pythagorean to apply. So we applied those. So those two identities. 1, and again, cosine of 2x. All right, let's go to 34. Let's see where we take 34. Do our next example. In 34, we've got the sine of x plus the cosine of x being squared. So let's go ahead and square it. All right, so that's equal to the sine of x plus the cosine of x times the sine of x plus cosine of x. So now we need to distribute. Multiply. Do the multiplication. So we got the sine of x to distribute through to both terms. So as we do that, we have sine x times sine x, which is sine squared x. And then we have sine x times cosine x, which is sine x cosine x. And now in blue, I'm going to distribute cosine x through. All right, so cosine x times sine x, which I'm going to write in the same order. Doesn't matter the order, multiplication's commutative. And cosine times cosine is cosine squared. So now what do we have? We have some like terms. All right. Go ahead and add those up. And we have our Pythagorean identity. So we have two things going on right now. So I want to recognize them, right? As you simplify, as you do your algebra, look for identities that you can use. So this is equal to 1. All right, so we simplify down. We got 1 plus 2 of the sine x, cosine x terms, and then hopefully you recognize double angle identity. Right? We're looking at double angle identity for sine. Right, so let's go ahead and write that down here in our notes. Double angle identity for sine. So this is equal to, right, sine of 2x. So in the end, we have 1 plus the sine of 2x. All right, so let's simplify it nicely. Did a little multiplication. We had to square it at the beginning, right? We had to raise it to a power of 2, so we expanded it and distributed. All right, and then we started simplifying, adding like terms, and applying identities. Let's go ahead and do the last one, 36. In 36, we have 1 plus the sine of 2x plus the cosine of 2x. All right, divided by 1 plus the sine of 2x minus the cosine of 2x. So as we look at moving on, we got to apply double angle identities. So let's go ahead and do that. So we're going to apply our double angle identities for sine and cosine. All right. So again, remember, sine of 2x equals 2 sine x cosine x. We know cosine of 2x is cosine squared x minus sine squared x. So again, right here, double angles. Let's go ahead and replace them. So it's equal to 1 plus, well, sine of 2x, 2 sine x cosine x plus cosine 2x, which is cosine squared x minus sine squared x, all divided by, in denominator, same thing, 1 plus sine of 2x, which is 2 sine x cosine x, minus, and again, it's important to keep your parentheses around these as you're plugging in these new expressions from the identities, because we will need to distribute, right, on that next step here. So don't forget that. So we will have to distribute this minus sign through to both terms with the double angle identity. Now in the numerator, nothing to distribute. We're adding the terms, but hopefully you're recognizing some identities. So if you look in the numerator, all right, I'm going to go ahead and do that. I've got, for example, I've got a 1 and a minus sine squared. Right here we have the Pythagorean identity. So remember, we have sine squared x plus cosine squared x equal 1, which implies if you were to solve for cosine, cosine squared x equal 1 minus sine squared x. So again, that's equal to cosine squared x. So again, Pythagorean identity. All right, let's go apply it. So right here beneath it, let's start working on this. So it's equal to, again, 1 minus sine squared. So I can replace those two terms with cosine squared x. And I've still got my plus 2 sine x, cosine x, plus cosine squared x, right? And that last one. And then denominator, let's go ahead and distribute our minus sign. So we have 1 plus 2 sine x cosine x minus a cosine squared x, and then plus a sine squared x. That's important. You have to distribute that minus sign through, so it becomes a plus here. Keep that in mind. Now, what do we have in the denominator? Well, denominator, I have Pythagorean identity, and I'm going to circle it. We've got a 1, and we've got a minus cosine squared x. So again, here's the Pythagorean identity, right? Again, if you solve for sine squared, right, what do you get? Sine squared x equal 1 minus cosine squared x. So again, you replace. So you're looking at that. Place that identity. So in the end, as we go to our next step, let's go ahead and write down our simplifying fraction. So in the numerator, we have cosine squared x plus cosine squared x. If you want, we can go ahead and add those together, right? Like terms. So we have 2 cosine squared x plus 2 sine x cosine x divided by, in the denominator, we've got the 1 minus cosine squared, which is sine squared x. All right, and we still have the plus 2 sine x cosine x plus the sine squared x. And again, we have like terms. Let's go ahead and add those up. So again, these are like terms here. Add them up. So we're simplifying this fraction down in our numerator, and if you want, we can go ahead and factor, or we can do that in the next step. Maybe we'll do our factoring in the next step. 2 cosine squared plus 2 sine x cosine x divided by 2 sine squared x plus 2 sine x cosine x. And now ready to go factor. So ready to factor out GCFs. All right. So what's our GCF and numerator? We got a 2. We got a cosine x. And our denominator, what's our GCF? We got a 2 and a sine x. So let's bring those out. So as we factor out the GCF, for example, of 2 cosine x, we're left with, right, inside here, we're left with a cosine x plus a sine x. All right? And then denominator, let's do the same thing. Let's factor out the GCF. Let's factor out the 2 sine x. And what are we left with in the denominator? We're left with a sine x plus a cosine x. And now we have common factors. So common factors, they divide out. 2's divide out. So in the end, all we're left with is cosine x divided by sine, which is our quotient identity. Cotan x. So applying the quotient identity, one of our basic identities we established back at the beginning, right, of our first chapter, quotient identity. All right? Yeah, cotan x equals cosine over sine. Just like tangent, just sine over cosine. And that's it. So I hope that helps. Again, I've been working with identities. In our next section, so we get on to 7.3, we're going to make some proofs. They're going to give us some identities. Right? We're going to prove they are identical by showing both sides identical. Not by just graphing it. We're seeing the graphs overlap and are identical. We want to be able to prove on paper that they're identical. So we'll continue on, but we've gone through our identities for this chapter, all the different ones, like sum and difference, Pythagorean, double angle, half angle, and of course our basic identities, reciprocals, quotients. Being able to use those to help us in simplifying. So we're going to have to be able to apply those and simplify to make proofs happen, which will be what we'll do next. That's it for 7.2.